Hi class, today we'll be talking about causation and correlation. First, we will go over definitions. 1. Causation, the action of causing something. 2. Correlation, the mutual relationship or connection between two or more things. For example, correlation can be variable A and variable B are related. And for causation, change in variable A causes change in variable B. What is the relationship? Causation versus correlation. While causation and correlation can exist at the same time, correlation does not imply causation. A correlation between variables does not automatically mean that the change in one variable is the cause of the change in the values of the other variable. Lesson objectives. 1. Work out if two variables are related. 2. Work out if one variable causes the change in the other variable. Part 1. Correlation. Correlation can be described by strength and type. Strength. This is a measure of how close the points are to falling on a straight line. The closer to the line, the stronger the correlation. Type. This describes if the variables are moving in the same direction. Now we will look at an example of strength. In the top graph, it is very strong because the dots are closely clustered along the line. In the second graph, it's moderate because the dots fall a little farther away from the line. The next example is type. In the top graph, a positive type is when the variables move in the same direction. As one increases, the other one increases too. In the bottom one, a negative type is when the variables move in opposite directions. As one increases, the other decreases. This is an example of when there is no correlation. There is no relationship between how the variables change. Part 2. Causation. Variables can be linked without one causing the other. Number of ways that two variables can be related without A causing B. 1. Reverse causation. Rather than A causing B, would B causing A make more sense? For example, a winter coat usage A correlates with cold weather B, but cold weather actually causes winter coat usage. 2. Confounders. Might some other variable C actually be causing both A and B? Example, basketball performance A and shoe size B are correlated, but height C drives both basketball performance and shoe size. Coincidence. If there is no reasonable connection, could it just be a coincidence? Example, from 2000 to 2009, the amount of cheese eaten per person A correlated with the number of people who died by becoming tangled in their own bedsheets B. These two have no correlation. Summary.
Created using Powtoon.